Hello there. In this video, I will be showing you how to divide special polynomials by x minus a. Please note that in this video, it is assumed that you are pretty good at using the reverse tabular method or the long division method to divide any polynomial. If you need a refresher on those methods, please stop this video and go back and watch those earlier videos on this channel. You must know how to do reverse tabular method and long division before you can proceed to learn this new skill. So if you are pretty sure you have learned how to divide any polynomial, you now may proceed. Here are the type of polynomials I was referring to. Here is x squared minus 9 divided by x minus 3, x cubed minus 27 divided by x minus 3, x to the power of 4 minus 81 divided by x minus 3. This is the sort of polynomials we're going to be dividing and then looking for pattern in the result of the division. So, like I was saying, you have to know how to divide before we proceed, because that's not the objective of this video. The objective is for you to examine pattern from division. So it might be helpful for you to stop this video and go divide this polynomial and then come back to see the result of the division. However, I will quickly go over the division of this one as quickly as I can. Here I have used the reverse tabular method to divide this. So here is the dividend all around, here is the divisor, and I have reversed this table to generate this. So basically, if you divide this by this, the answer will be x squared plus 3x plus 9. In the same way, if you go ahead and divide this using long division or this reverse tabular method, you will get this. You will get this quotient, x plus 3. This is the one that I just showed the screen briefly. And if you do the same thing for x to the 4th minus 81 divided by x minus 3, you will also get this polynomial quotient. So now we begin to examine the patterns that are in these answers that we have. So let's see, this answer here, and this answer here, and this answer here. Okay, but first let's look at what we are dividing. We are dividing here, we're dividing difference of square. So I can write that as x squared minus 3 squared divided by x minus 3. I can also write this one like x cubed minus 3 cubed divided by x minus 3. And I can write this one as x to the 4th minus 3 to the 4th divided by x minus 3. So basically, you will see that these powers, these exponents are the same. They are the same. So when I say that we're actually doing differences of powers of x, differences of powers of x and powers of 3, you can see what I mean by that. This is second power minus second power, third power minus third power, fourth power minus fourth power. So the dividends are differences of powers of x and powers of 3. That is the very first observation. The next observation is that if you look at each of these, look at this one. The degree of this quotient, is 1 less than the degree of the dividend. So look at the quotient. This is x to the power of 1. This is x to the power of 2. So if you're going to be generating quotient from this kind of division, the very first term will be the exponent will be 1 less than the exponent of the dividend. Look, the exponent of the answer, the quotient, 2 is 1 less than 3. 3 is 1 less than 4. That is what I mean by the degree of the quotient is 1 less than the degree of the dividend. Okay, so the next observation is that the terms of the quotient are products of powers of x and 3 and powers of 3. So not only do we have up here powers of 3, see we have powers of 3 over here, power of 3 and power of x and power of 3, power of x and power of 3. We also have in the answer power of x and then power of 3, power of 3, power of 3, power of 3, power of 3. So we have powers of x and powers of 3 in the quotient as well. So that is what I'm trying to explain here. The powers of x and powers of 3 on both, on the quotient. Okay. So I will show you on the next screen how the powers are, how they are related together. Now let's look at the exponents for x and the exponents on 3. All right. So you can see over here that the first one, the exponent of x here is x to the power of 1, and this is plus 3 to the power of 1. Okay. Here is x to the power of 2. In the next term, the x is actually decreasing from 2 to 1, while the power of 3 is increasing from 1 here to 2 here. So x is going down by 1, the exponent is going down by 1, and the exponent of 3 is going up by 1. 3 to the power of 1, 3 to the power of 2, 3 to the power of 3. Actually, there's a 3 to the power of 0 here if you start from here. 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3. So the last thing to notice is that each of these terms is positive. Each term is positive. There are no negative here. Okay, now, so there are four. This 5 observation is going to help us to be able to generate this kind of answer, this quotient, without actually doing any division. Okay. Here's an example in which we're just going to use the pattern that I talked about to do all our division to get the answer we're looking for. Okay, we're just going to do use the pattern. So as you can see here, the first thing is to rewrite the problem so that they will have the written as powers. So this is a power of x minus a power of 3, because 243 is actually 3 to the power of 5. Next is to write the first term, which is very easy because this is x to the 5th, x to the 1st, 5 minus 1 is, so the quotient is, the degree of the quotient is 1 less than the degree of the dividend. So 1 less than 5 is 4. So you're going to start off with x to the 4th. If this was x to the 10th, this would have been x to the 9th. If this was x to the 20th, this would have been x to the 19th. I think you get the point. The next term is going to be created. It's going to be formulated by writing the exponent for x, for the x to go down by 1. We started with 4. The next one will be x to the 3rd, and the next one after that will be x to the 2nd, x to the 1st, and then x to the 0. Now, but hold on, there's a 3 here, which is coming from 3 to the power of 1. So there was 3 to the power of 0 here at first. So if you like, I can put 3 to the power of 0 here, 3 to the power of 0, which actually 1. So because anything 3 to the power of 0 is actually 1. So 1 times x to the 4th. So is x to the fourth. So now you can see that the degree of 3, or the power of 3, is starting from 0 now, is going to 1, and the next one is going to go into 2, which is 9. So now this is what I was saying, that we have 3 to the power of 0, 3 to the power of 1, 3 to the power of 2. The exponent of 3 is increasing, whereas the exponent of x is going down. So I'll show the remaining one. Again, the exponent of x is going down by 1, and the exponent of 3 is going up by 1. X going down and 3 going up. 3 to the power of 1, 3 to the power of 2, 3 to the power of 3. Okay, so this is the final term, because we ran out of exponent for x. So x to the power of 0 here, x is going to have an exponent of 0 here, because it's at 4, 3, 2, 1, 0. If you do the math, it looks like this: 81x to the power of 0. That's x right there, to the power of 0. My x is not really very good, so let's see if I can change that to a better x. So we x to the power of 0. And now anything to the power of 0 is 1. You can see the x has gone down to 0, and the 3 has gone up. So here is another way of writing the same thing. So I've been trying to use 3 to the power of 0 to start with 3, so they can have everything in place. So now on the next term, you can see that 3 is going from 0 to 1, the power, whereas x is going from 4 to 3. On this next term, 3 is going from 3 to the power of 1 to 3 to the power of 3. X is going down from x to the power of 3 to x to the power of 2. And on this last one, we can see that, not the last, second to the last one, 3 is going up from 3 to the power of 2 to 3 to the power of 3. X is going from x to the second to x to the first. And now we have the very last one. 3 has gone from 0, 1, 2, 3, 4, I mean the exponent. And then x has gone from 4, 3, 2, 1, 0. This is what you need to bear in mind as you apply this pattern to do any problem in the future. As with anything in algebra, so if you do a particular case that we know numbers for, we can actually replace this number with a variable now. Say, I want to know what happens for any value, apart, not just 3, any value. So we replace that with A. A is for any value, okay? So you can see that we've replaced 3 with A. The structure is still the same as before, but we replace 3 with A. So we're gonna, everywhere you see 3 here, you're gonna replace with A. And that's how we got this structure, this formula out. This is a formula you can always use to generate any difficult one, any other pattern like this. In the next video, we're going to see some other concrete examples. Suffice to say that if you master this pattern, you will be able to divide this kind of setup without actually doing any division. Well, this is the end of the video. I hope that helps a little bit.